Welcome to the last video of this unit. Okay, don't get all excited. This is not the last video of the whole year. This is the last video of this unit. And in this video, you will learn about the Vsepr theory. Vsepr theory states that V is the valence shell electron pairs repulsion. I don't know if there's any S in these. Valence shell electron pairs, I think pairs repulsion. I think that's how it is. But that's what those letters are. Valence shell electron pairs repulsion. So what is this for, basically, right? This is to tell us the shape of molecules. Okay, shape of molecules. And we are responsible, as a chemistry student here at Bowie High School this year, you're responsible for 4 different shapes, I believe. 4. Let's see. First one is linear. Okay, linear. It makes a line. Pretty simple. Second one, it's at an angle like this. It's called angular or bent. Okay, you could pick either way to say it, whatever you like. The third shape is if you have something in the middle like that and it sticks out, 3 things connected to it like this. This is trigonal, like triagonal. Planar, it's flat. Okay, trigonal planar. And then another one, so we do have 5 shapes, not 4. So trigonal planar. And then trigonal pyramid. It's going to stand on like 3 feet like this. Okay, because there's going to be lone pairs, imaginary lone pairs up here. That pushes these things down, so then we have the trigonal pyramid. And it's called trigonal pyramidal. Trigonal pyramidal. Okay, and then the last one, alien looking thing. 3-foot tripod tetrahedral. Okay. So it's like, if you remember from last year, you learned about all these, the viruses, right? Some of them look kind of like that. 8 legs, something hedral. And so tetra means 4, okay? 4 things connected to it. 4 things connected to the middle atom. So it's pretty simple there. So 4 or 6 different shapes here, 5 different shapes. We have linear, angular, bent, trigonal, planar. It's a flat triangle. And then trigonal pyramid, it stands up like a pyramid. And then tetrahedral. Alright. So let me try to show you that with some model kits here. I have a couple model kits here. And so linear is anything that basically is 2 things bonded like that. Makes a straight line. Okay? It can have a double bond and still be linear. And so that's linear. So any 2 things here, ting 1, ting 2, this thing here, white ball and white paper here, show up very well. Yes, it does. So yeah, like this, yeah, work out. See, I can work out my forearm here really nicely with this linear thing. Okay, and so for bent, so that's linear. Let's keep these examples out. And then for bent, you can have something that looks like this. Hold up, I'm making it. Hold on. For bent, you have a bent looking object like that. Okay? Guys, this is just a model kit. The actual items, the actual molecules will be a lot closer. There's not that line that separates it like that. Okay? So, this is a better representation of the water molecule. So these are water molecules here. This water molecule, oh, there's a drop of water on my hand. So this water molecule is a little better representation of that. The lines just to show you the bonding, okay? And then so you can have here we go. What is this? This is a nitrogen. Perfect. Nitrogen goes with this here. So this is here This is a tetrahedral trigonal pyramid. Sorry, trigonal pyramid. See, it stands on that. We can't see it very clearly there, but if you can look this way, see, it does not flat down on the paper, so it stands like it's a pyramid. And then we can also have tetrahedral. I don't think I have a boron. I need a boron to make the planar, trigonal planar. I don't think I have a boron in my kit, so we just won't make one. It's not very common. And then you have tetrahedral, this thing that stands on. You can flip it like this, see? So tetrahedral, put it down. If you remind Miss Carrasco's class, look up on the ceilings and you see all these different shapes hanging off the ceilings. Okay, so pretty nice there, pretty convenient for you to just take a look and see what they kind of look like. So our job is to draw Lewis dot structures for these things. And our job is to draw Lewis dot structure for these things, sketch the model of it, tell us the shape, and whether it's polar or non-polar. And I did go over polar, non-polar in the video of the covalent bonding basics, polar, non-polar. Just a quick review here. Polar means it is not balanced, non-balanced distribution of electrons. Okay, I'm not gonna write all that out, but you know that. Polar means, non-polar means balanced, equal distribution of electron. All right. As far as polarity, now I'll talk to you about that in the slides, in the slideshows, in the note slides. So there will be a note slides video as well. Shouldn't take long. It should be about 10 minutes long. Okay. So here it is, Lewis dot for CH4. So first you draw the Lewis dot. You draw the carbon, 4 dots. Strategically, we've already done this one, but again, it never hurts to practice a little more. H, H, H. Draw a clean version of it. If it's not, you gotta clean it up. Alright, so carbon here. So I'm gonna clean it up like this. It looks like that. Hydrogen, hydrogen, hydrogen. What I should have done, take that back. Let's restart. Carbon, I'm gonna sketch my drawing over here. Alright, so draw my Lewis dot there. If I need to clean up, I still have the other half to clean up. So sketch the model. The model is gonna be a carbon in the middle. With 4 of them, it's gonna bond like this. It looks like that, and the shape is 4 things connected. It is tetrahedral. So it's like up here. Okay, this shape is called tetrahedral. So your shapes are up here as well. If you look, there's 4 things connected to the central, so it's tetrahedral. So you tell me the shape. Tetrahedral. Okay. Is it polar or non-polar? So if you look at it, it's all the same thing around. Look at the Lewis dot. It's all the same things around, so it is balanced, so that it is non-polar. Okay? Opposed to something like NH3. Go down to NH3. NH3, nitrogen. You draw 1, 2, 3, 4, 5. 5 valence electrons. So there's a hydrogen over here. 3 hydrogens. Hydrogens there. Hydrogens there. Connected, connected, connected. And so if you have the model, you'll make it and you'll draw it looking like this. If you don't, it's okay. Guys, realize that there's a lone pair on top, and what it's going to do is going to push these things downward. Okay, it's going to push those things downward to make it a pyramid instead of a flat or a tetrahedral. It's going to push it downward and make a 3-footed little creature. And this thing is called a trigonal pyramid. Trigonal pyramid. Okay. And so, is this polar or non-polar? Is there an equal distribution of electrons? So if you see dots on one side, this is a lone pair. If you see a lone pair on one side and there's no lone pair anywhere else, then it is going to be unbalanced, because there's no lone pairs down there. Or if there's more or less, you compare. If it's more or less, then it's not balanced. So this is polar here. Okay. So you do that for carbon dioxide, oxygen, water. Okay. And then nitrogen down here as well. Remember, you have to connect, let's do nitrogen. I'd like to do nitrogen with you here because it's a little special here. Nitrogen, you have 1 dot, 2 dot, 3 dots, 4 dots. Okay, there's 5 dots. But think about where you're putting the other nitrogen. So you know where to put that extra dot. So I'll put the extra dot on the back because I know I want to face the single ones to each other. So nitrogen, 1, 2, 3, 4, 5. I can face the single ones to each other. So I can connect 1, 2, 3. Okay, you gotta clean that up. Triple bond, 3 lines in between, 2 lone dots on the end. Okay. When you make your model, if you were to make your model, it'll look like this: 2 balls there with 3 lines, 3 triple bond in between. And let me try to make that for you to show you, just in case you don't get to make it or you don't have this kit in your classroom. And you likely will if you're in my class. If Miss Carrasco is going to be out till then you probably won't. So I'll let you see it like this. Look at that. Triple bond. 3 bonds between these 2 blue spheres. So 3 bonds in between them. And what shape does it make? Just, if you don't see those bonds, if those bonds are imaginary, these 2 things here will make a line so that this is linear. You only look at the spheres, the atoms. Okay? And this is linear. Is it balanced? Of course it is. So it is nonpolar. Balanced, nonpolar. Alright. And so 2 weird ones here that I didn't ask for the shape. So you draw there's 2 carbons, so you draw 2 carbons in the middle first. 1, 2, 3, 4. 2 carbons in the middle. This one draws small because there's a lot of them. And then there's 4 hydrogens. So when there's carbon hydrogen, you split them up. 1 carbon, 1 hydrogen over here, 1 hydrogen over here, 1 hydrogen over here, 1 hydrogen over here. Divide up the carbon so that it goes, the hydrogen, so it goes to both carbons. Each hydrogen have 1 dot, 1 dot, 1 dot. You'll connect it to that, connect 1 each to the carbons there. And then the carbons in the middle, you'll have 2 single dots there. Okay? So you have a double bond between the carbon. So to clean that up, which I should have cleaned up, I didn't have room. I don't have room. So carbon, double bond to the carbon, then 2 hydrogens. And those hydrogens want to be as far away from each other as possible. Guys, these bonds, they need to be as far away from each other as possible so it actually looks like that. Okay. The model kit will show that as well. We'll show a double bond like this, and then 2 hydrogens. And this one, it is also non-polar. Sorry, non-polar. It's balanced. And let me show you that model here. Boy, oh boy. Show you this model, and then you can finish the rest of this. Here's 2 carbon. 2 black ones are carbons here. They double bond to each other. And there's 4 hydrogens. We got 3, 4. 4 hydrogens. 1, 2, 3, 4 there. So that's what it looks like. You see that? So it is, you cut it top and bottom, left and right. It looks symmetrical. It is balanced. So that is for C2H4. 2 carbons with 4 hydrogens. Alright, please finish this. This concludes that whole Vsepr part here. So Vsepr, you tell whether or not they atoms, what shape they have. And then polar and non-polar tells us whether electron distribution are equal or not, or balanced or not. Okay, so this concludes this unit as far as the material goes.